Probability, Unit 11, Day 2. This is Mr. McGough in R12, and I'm going to be going over our notes for Day 2. So first, combinations. What is a combination? A combination is an unordered selection of R objects from a group or a set of N objects. So the permutation order matters. In a combination, order does not. So what happens? Well, we end up getting for 0 less than or equal to R less than or equal to N, we have a combination of N things taken R at a time becomes N factorial divided by R factorial times N minus R factorial. So you saw with permutations, it was just N factorial over N minus R factorial. Now, since order does not matter, we have to take a look and remove all of the permutations of the order. And that'll become more clear as we go through problems. So find the following combinations. 7, choose 4. Combination of 7 things taken 4 at a time. This would be 7 factorial divided by 4 factorial times 7 minus 4 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And 7 minus 4 factorial is 3 factorial. 3 times 2 times 1. So we see that we can eliminate some of our fraction here. 3 times 2 times 1 is 6. I'll remove that as well. And we get 35. So if we have 7 items, 7 unique items, and we're told to choose 4 of them, and the order doesn't matter, then there are 35 different ways to select that group of 4 items. Problem number 2, combination, 6 items taken 3 at a time. How many different ways can we do that? Well, on the top, 6 factorial divided by 3 things and 6 minus 3 things. So here we have 6 factorial divided by 3 times 2 times 1. 6 minus 3 is also 3, so 3 times 2 times 1. 3 times 2 times 1 I can remove from both the top and the bottom. And 3 times 2 times 1 is 6. So 5 times 4, 20. 20 ways to pick 3 items from a group of 6 where order does not matter. So I bet you know that there's going to be a button we can use in our calculator. There is. Inside of our math button, under probability, we have NPR, which we used in the last lesson, and NCR, permutations versus combinations. So we're going to do number 3 using our NCR button. So we're going to go down to number 3, select that. Oops, clear. Actually, I have to put in the first number first, so I'll put in 12, math, probability, NCR, 12, choose 3, 220. Let's check that work against doing it by hand. This would be 12 times 11 times 10 times 9 times etc. Divided by 3 factorial times 12 minus 3 is 9, so 9 factorial. So I will eliminate. "12 times 10 times 11 divided by 6 will change. 6 goes into 12 twice. 10 times 11 is 110, times 2 is 220. So we see that the button works. So how do we apply these? Well, here's some problems that we can take a look at. We're picking books from a stack of 32 books. The order of the books you choose is not important. That's what you're looking for to determine whether you're going to use combinations or permutations. For a permutation, order does matter. For a combination, order does not matter. So here we're going to have 32 items, and we're going to choose 7 of them. We're now going to put this into our calculator. 32. Choose 7. That's a lot of options that we have to choose those books. So that's 3,365,856 different ways we can choose 7 books from among 32. If order is important, then we're using a permutation. 32, permutate 7. Well, what are we really going to do here? Well, we're not going to divide by that 7 factorial. We're only going to divide by 32 minus 7 factorial. So there should be 7 times 6 times 5 times 4 times 3 times 2 times 1 times more options. So we'll put that in the calculator. We'll do 32 math, probability, and PR, permutations, 7. So that E10 means times 10 to the 10th. So we have 16, 963, 914, 240. Hundreds of thousands, hundreds of millions, billions. 16.96 billion options for choosing those books if order does matter. Trying to decide whether to multiply or add combinations. Well, if you have unique events and each of them has their own probability, and they are sequential, we would multiply our probabilities. So for example, Blockbuster is having a special on new releases, and Mr. Murtara wants to treat Gertie to a relaxing night at home. Then it lists all of the potential new releases. By the way, Blockbuster, if you've never heard of it, is a video rental service they used to have back in the day. I think there's one existing store still up in Alaska somewhere out in the hinterlands, but you actually used to go to a store to rent movies. So the new releases are there listed. How many different combinations of movies can Murtara rent if he wants exactly 2 comedies and exactly 3 family movies? Now, it doesn't matter which order he picks them in. So for comedies, there are 12 comedies. From among them, he will choose 2. So how many different opportunities are there for him to choose those movies? 12. Math, probability, NCR, 12, choose 2. 66 ways. And then he's going to choose exactly 3 family movies. 9, choose 3. So we're going to, do 9, math, probability, choose, again, order doesn't matter, 3. There are 84 ways he can pick 3 family movies from among 9 family movies. Now, each combination of comedies is separate from your combination of family movies. So we're going to multiply these together. So 66 times 84, 5,544 options. Now he realizes he really only has enough money for at most 2 movies. Changes his mind and he doesn't care what type of movie, how many different combinations are possible. Well, we know he's going to choose 2. But it's not just from comedies and family movies. So how many total movies can he choose from? 12 plus 8, that's 20, 27, 32, 41. So from 41 movies, he will choose 2, and he does not care which order he chooses them in. So, 41, math. Order doesn't matter. NCR, 2 of them. 820 options. The other way to think about that, if you just want to think it through, would be, well, let's see. His first movie, he can choose any one of 41 movies. His second movie, he can choose any of the remaining 40 movies. And then, if order doesn't matter, he can choose the first one first, or he can choose the first one second. 2 different ways where that first movie ends up. So here's what we really have. 41 times 40 divided by 2. What is that really? Well, it's 41 factorial divided by 2 factorial times 41 minus 2 factorial, which is all the numbers, that's 39 down to 1. So if we, instead of writing all of this out, just eliminate everything from 39 down to 1, we have 41 times 40 on the top, and then because order doesn't matter, we divide that by the 2 different ways he could have chosen those 2 movies. A and then B, or B and then A. Letter C. While he's in the store, he runs into another teacher who is looking to treat her husband to a movie night, and she was looking to rent 2 action movies and 2 dramas. How many different combinations are possible for her? Well, she's going to choose 2 of 8 for action movies. And dramas, she's going to choose 2 of 7. So for each of these, we'll go into our calculator. 8. Choose 2. 28 options for action movies. And then drama. 7. Choose 2. 21 ways to choose from amongst those. So there are 28 different combinations of action movies, 28 different combinations of action movies, and 21 of drama. So we will multiply the 2 numbers together. And we get 588 total combinations for those 4 movies. Next, number 6. A popular magazine has 11 articles. You want to read at least 2 of the articles. How many different combinations of articles can you read? Well, if you want to read at least 2, and there are a total of 11, you could read 2, 3, 4, 5, 6 of them, 7, 8, 9, 10, or all 11 of them. So each of these has its own possible combination. But let's say, for example, you choose 2, and then you decide to read a third. That would be its own grouping, because now instead of reading 2, you read 3, but it may include the 2 you've already picked. So instead of multiplying these together, we're going to add these options together. So I'm not going to bore you with the calculator work. I'm just going to write down my numbers. For each of these, it is 11. Choose n, where n, or r, I guess. We can use r. So out of the 11, we're going to choose either 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11. If I choose 2, 55 ways to do that. Choosing 3, 165 ways. Choosing 4, 330 ways. Choosing 5, 462. Also 462 ways to choose 6. So here we have our symmetry beginning. On 7, we have 330 ways. On 8, we have 165 ways. For 9, there are 55 ways. For 10, well, you're only leaving one book on the table. There are 11 ways to do that. And if you're going to read all 11, there's only one way to read all 11 of them. So we'll add these together. Do quick mental math. Okay, that's 2,036 different options. No, that wasn't mental math. I did it in my calculator before I started the video. So 2,036 total ways to be able to read 2 or more of these 11 articles. Next, Reno High School football team will have 10 games next season. Gisela wants to attend at least 4 of them. At least 4. So, how many different combinations of games can she attend? Well, 10 choose 4. She could choose 5, 6, 7, 8, 9, or 10. If she wants to watch exactly 4 of them. 10. Math. Probability. Choose. 4. Enter. 210. So as we put these into our calculator, see that for 10 choose 5, we get 252. 10 choose 6 is 210. 10 choose 7 is 120. 10 choose 8 is 45. 10 choose 9, well, she's only missing 1, so there's 10 ways to do that. And 10 choose 10, only one way to attend all 10 games. So again, we're going to add these together. As you can see, I did these offline. So 210 plus 252 plus 210 plus 120, 45, 10, and 1 more. A total of 848 ways for her to watch 4 or more of the 10 total games next season. Hope you enjoyed the video. Remember, permutations, order matters. Combinations, order does not matter.